We are now going to discuss a few common mistakes that we, the programmers, tend to do, with the hope that we will avoid them. You can pause the video and take a look at the names of these common mistakes. Whenever you're ready, continue playing the video so that we discuss each one of them. This is an example of code that does not do what the programmer who wrote it thought it should. Take a look at it, and again, you can pause the video for as long as you need and try to figure out what is wrong. We have a main method, we have a program, and then we have a variable n which is declared and initialized at value 1. The condition of the loop says that as long as n is less than 100, we print a particular statement. Perhaps the title of the slide gives away the problem here, which is the fact that we never change the value of n within the loop body. In other words, n will always be 1, n will always satisfy the condition, so the loop body will continue executing forever. This is obviously not the intended behavior for this particular program, and so this is a common mistake that we make. We create infinite loops by failing to update the variable that we were thinking would control the loop. Here is another example of a common mistake. The loop you see on your slide is not infinite. We have called it almost infinite because it runs for a really very long time. For example, it could run for 4 hours in a common laptop these days. Pause the video and see if you can find out what the problem is. Take a look at the condition in the loop. This loop will continue executing as long as I is greater than 0. What is the starting value? The starting value of I is 10, which is already greater than 0. Great, that will allow us to execute the loop at least once. Then, what have we done? The increment operation will make it so that every time the loop executes, I will become 11, 12, 13, and so forth. I will be positive for a very long time. If the intent of the programmer was to execute this loop 10 times, the correct statement would be to decrement I. So instead of I++, should be I minus minus. Now, why is this an almost infinite loop? Well, I will continue being incremented until it gets the maximum integer value available in the system. And after that, it will wrap around, it will become negative, and then, and only then, will the loop exit. As you can probably imagine, and as I already mentioned, it will take a long time until that happens, definitely longer than the programmer initially probably thought. Here is another kind of mistake. What is the mistake here? Pause the video and see if you can figure out what is wrong. The print statement inside the loop, it says that this line is going to be printed 5 times. In other words, the programmer assumed that the body of the loop is going to be executed 5 times. Is this correct? I gets initialized to 0, however, the condition says I less than or equal to 5. If you take a look at the common practice that we talked about earlier, you will see that we have said if we want a loop to execute n times, the variable should go from 0 to strictly less than n. If we want this loop to execute 5 times, the I variable should start from 0 and the condition should be strictly less than 5. In other words, this loop will be executed 6 times. And we call this fence post error because it is off by 1. these errors are also quite common. Pause the video for this one as well and see if you can find out what is wrong with it. We read a number from the keyboard through the scanner class, and then we also initialize the variables number and sum to 0. The intent of the loop, as it says, is to read integers from the user until 0, and at that time we will print a sum. The problem is that the condition of the loop says while the number is positive. The initial value of number is 0, which means that the control will never enter the body of the while loop, not even once, because the condition is false from the very beginning. This is a case where we have skipped the loop while we intended to run it at least once. In such a case, for instance, we could have a do-while loop so that the loop runs at least once and the number gets updated within the loop. Finally, examine this particular piece of code. Pause the video and see whether you can figure out what is wrong with it. Probably the title of the slide already gave it away. But this is definitely a common error, maybe not as common as the previous ones we've seen, but definitely we should be aware of this kind of mistake. Although it may surprise you, this particular code does compile, so the compiler will give us no problems about it. We can have a semicolon at the end of the statement in a while loop, and that will result into the while statement running just once. In other words, it is as if it is nulling the effect of a while loop. The statement will only run once no matter what the condition is. And that is because the semicolon has been misplaced.